Morning, everyone. This is Sumit from Labellerr. Joining us, George Williams from GSI Technology. He's a
Hmm.
director and data science in data science and machine learning. So, hi,
Yes.
George. How are you? Morning there.
Good. Good. Great. Good to meet you, and good to be here talking about this important topic.
Cool, Miss. We are just interested to know that we have talked with several people from healthcare and other sectors from the AI, but you are the pretty unique because you are based for networking and telecommunications. So how is it all about? Means how you use data science in those sectors?
Sure. I think it's important to sort of I think look at what is impacting a lot of these domains and verticals that you've been looking into. Healthcare, autonomous vehicles, um, cybersecurity, fintech, and AI. Um, I think you understand this, and I think most of your audience understands it. Is driving a lot of the innovation and a lot of the progress in these fields over the past few years, and that's accelerating rapidly, um, even further. The advances that we're seeing, the data-driven nature of these applications, and what we see in the compute hardware area is that the innovation needs to actually progress even faster. If we look at the computing hardware that's existed for the last 50, 60, 70 years, it's been very Intel based, it's been very CPU based. The microprocessor design hasn't changed fundamentally. And that convergence was very useful from a business perspective, but what we're seeing right now is that workloads have different requirements from the hardware. They're more data driven. They're more driven by decisions that need to be made locally to where the data is collected, right? So we need compute at the edge of the network, not just in the data center, right? We need powerful compute at the edge of the network, and closer to where the sensors are collecting the data. So for example, in healthcare, right, a ton of sensors now people are wearing in order to get a sense for their health, right? So instead of capturing all this data and shipping it to a powerful data center, what we need to do is to be able to make those AI decisions locally. And so compute, as opposed to being centralized, as it was for 50 or 60 years, now we're starting to see a divergence of different kinds of compute hardware to handle these different kind of scenarios, data-driven and IoT in particular. So now in the hardware world, we talk a lot about this sort of silicon divergence, right? The novelty in hardware. And I think we've all seen, I think, some of the stories around better compute power in our phones, better compute power, low power compute, embedded machine learning, embedded AI in all sorts of devices. And we're seeing, at least from my perspective, a divergence of different kinds of microprocessor designs that are uniquely tailored and built to handle different kinds of workloads. And so, right, so this is very low on the technology stack we're talking about, right? The hardware that's running all of these software applications and AI applications. And so we're seeing this diversity of different kinds of compute, right, to handle the workload of the future. And so data science, right, obviously machine learning, AI, that factors heavily into this because it's actually guiding where we need to go with how we design computers and silicon and chips to handle all of these new kinds of applications. So yeah, it's a very exciting area to be in data science, and to see it from a unique perspective, which is from the silicon view. It's a very exciting space to be in. To use data-driven methodology to guide where we're going with advanced compute hardware and future compute hardware. Yeah.
Right. So most of the people that we talk to, the biggest challenge that they face is data collection. But in the hardware case, you are kind of building that is collecting the data. So I suppose data collection is not a big issue for you, right?
That's not necessarily the case. So, for example, when we're talking about, traditionally over the last, ever since the first transistor was created, creating, designing computer chips and microprocessors has been a very human-centric kind of activity, right? We sort of, we train the best and the brightest to be able to create these floor plans for these chips. And by floor plan, I mean how we lay out the transistors for memory, for compute, for cache, all these kinds of capabilities you need to squeeze into a small surface area for a chip. Well, it turns out that we're starting to see an inflection point here. It's so complicated what needs to be done to design computer chips that we're starting to look at leveraging algorithms, and in particular, the last few years, AI to actually design these chips. And with any kind of AI activity, right, we're going to be feeding it examples. We're going to be feeding it data. And so the human-centric, what I envisioned in the next few years is that AI is probably going to be, at the end of the day, designing the chip from basic specifications. But that's going to be data driven. And so now the human is moving to sort of in the data science and machine learning realm. People are going to be collecting the data, cleansing the data, figuring out what the right inputs need to look like for the AI to actually learn how to design future computer chips. And we're already starting to see advances here. Google announced recently their efforts to have AI completely design the specification for chips. We've seen this in the data center where Google and Facebook are leveraging algorithms and AI to intelligently route data and applications to the hardware that is the best fit for it, and to optimize power management at data centers. So a lot more AI that's going into hardware, both at the macro and the micro level, and the data scientist, the human data scientist, is central, right, to this role, because as you say, right, garbage in, garbage out, right? The only way these things can learn effective algorithms to do these tasks is if we feed it the right data. And so a lot of human activity involved in even these activities in manufacturing and creating chips.
Yeah, sure. So means in various industry, we see that AI brings lots of automation. So how chip building and those circuit designing and those kind of things, that hardware designing, AI means AI can bring automation or improvement or process enhancement. How it will work in your case?
Yeah, definitely. So right now, it is like a lot of industries in the sense that, we do tend to, I think a lot of us in this industry, we do tend to feed the hype a little bit with complete autonomy. But I think what's happening right now is really a good hybrid between the humans and the machines. So there's a lot of workloads that it's good to sort of offload to robotic process automation or to algorithms. And so what we're seeing is that the AI assistant and the human being, right, they're actually assisting each other in solving a problem. And so that's what I'm seeing now. I'm seeing a lot of progress here in human teams leveraging AI to do a lot of the mundane tasks so that, right, they can truly innovate. And I think that's the trend that I'm going to continue to see for quite a while, at least in my industry. And I think that's true in general of other industries I've been in, right? In cybersecurity, for example, it's tricky to have complete autonomous cybersecurity, right? You still need a human at the end of it, sort of reviewing those decisions. I think we're seeing this in healthcare with the radiology. We're not completely replacing the radiologist or the doctor, right? But AI and algorithms and data science can really be a useful tool that these experts can leverage to do their job better, right? Whether it's trying to diagnose some kind of issue with a patient or trying to design a really complicated computer chip. The problem is essentially the same. And AI can be a huge assist, right, to these experts who need to really innovate very quickly.
Right. Right. So what is the biggest challenge for you, especially while building this AI-based product? Is it
Yeah,
data
so
collection or other process?
yeah, I think, at least in my industry where we're talking about using artificial intelligence to actually design computer chips, it can be tricky to actually collect the right kind of data in which to inform an algorithm to learn. Part of this is because of proprietary reasons. So, obviously, when we talk about data science, machine learning, we talk about volume and velocity and the various V's we need in order to accomplish data science tasks. And variety is a very important aspect to the data that you're feeding a lot of these algorithms, especially ones based on deep learning. And so that can be tricky in the chip industry where it's highly proprietary, right? There isn't a whole lot of sharing of chip design in the industry. And one of the reasons for that is that it's very expensive, right, to create a chip. First chip efforts, first family of a new kind of microprocessor, that can take the order of millions of dollars, right, in a couple years, right, to design a chip. So people don't necessarily want to freely give away, right, all of their design files, right, in order to, create this nice uber awesome model that can actually spit out, right, unique computer chips. And so the proprietary nature, I think, of the business context, I think, in which we all work on, right, that can be sort of antithetical to kind of some of the data needs we might have in which to create these powerful algorithms. I think it's true in the big pharma, in the pharmaceutical industry. Like there's not a whole lot of sharing of drug design details, right, which totally makes sense, right? Costs billions of dollars to make these drugs. And so I think we're seeing some efforts to promote this kind of sharing without releasing a whole lot of very specific proprietary information, such as federated learning, notions of differentially private machine learning. And that I think will help to create these sort of sharing ecosystems for the betterment of us all, while individual companies don't need to offer up very specific information about their secret sauce and how they actually make money. Yep.
Exactly. Means it's a kind of, if we talk technology wise, means people often say that while doing the experimentation with the several model and train them, and while going to the production level, they're completely different ballgame. So how it is in your case?
In my case, it's mostly still a lot of research. A lot of the work for automating, the development and even the fabrication of hardware, it's a research activity. We're not at a point like in, say recommendation engines, right, where there you need a very specific ML operations pipeline, right, because you're constantly getting new data in. Your models are drifting significantly. It's something that you need to automate at scale, right, because you have systems that are working right now, and they need to continue to work at high degree of accuracy and high performance. So I say in my industry that kind of thing, that need to operationalize and productionalize research, we're still in our infancy. So there's probably less of a need right now for that kind of MLOps compared to some other industries. But in some sense, we can leverage a lot of the great work that's now being done to create these mature pipelines in other industries, such as fintech and such as cybersecurity and such as the healthcare industry. But yeah, I think it's a challenge across the board, right? You spend a lot of time doing research and you get your insight and boom, you want to put it into production, right, immediately. But there are a significant number of challenges to do that. Fortunately, we have a lot of companies that now are interested in helping creating products. You're starting to see turnkey solutions at the public cloud for creating these data pipelines that incorporate machine learning at scale. So there are a lot more tools available for your DevOps team and your data science team to leverage in order to productionalize, that research and those models and all of that data science.
Right. So it means
Exciting times to be doing data science and
right,
AI.
right.
Yeah.
Yeah. So while we talked about tech stack, so do you see any gap in current tools that you are talking about, or is it good enough for in your case?
Yeah. So as someone who puts both a research hat on and an engineering hat on, I think for the most part, I've leveraged open source for much of my career. In open research, right? If you're in an AI, right, you've got a stack of papers that you're always reading. And so I think there's, in terms of availability and variety, there's so many tools to choose from and to investigate that I don't think there is a lack, right, of tools. And a lot of them are openly available. I think, at some point, it's the interoperability of these things, right? That becomes the pain point, right? So, I want to train a model over here in my Jupyter notebook, and that's great. And I serialize that to some kind of format. What systems can take that kind of model? And then what systems can take a large model, right? Like billions of parameters, for example, and what systems can scale that out in a way that's useful. So I think, like I said, like a lot of efforts and companies out there that are starting to address this. But I see it as analogous to where we were in software engineering maybe 15, 20 years ago, right? Where you had a bunch of silos of amazing products and ecosystems, but they didn't really all talk to each other. And so we need more of that, because there are a lot of great tools out there that solve very specific problems. They just need to talk to each other
Right.
a little better. Yeah.
Right. So now we are approaching to the closing. So I just wanted to ask you the one last question: that how do you see the AI adoption in the industry, overall industry, means all the industry, in next 5 years? What's your opinion?
I'm going to be honest with you, which is I thought we would be in AI winter right now. And the notion of AI winter, right? There have been previous AI hype cycles in the past, and they've peaked, and then there's been a dramatic loss of interest, right, in terms of products, in terms of funding, in terms of ideas and innovation. And so I cut my teeth on machine learning, neural networks, deep learning a good 10 years ago at New York University. And so I've been predicting the last few years that, right, we would be seeing a drought in terms of AI innovation. And I think we're seeing the opposite of that, right? It continues to grow and to expand and to get a lot of interest. The AI startup ecosystem is the strongest it's been since I've seen it. A lot of AI efforts are starting to succeed, right, versus fail. And so I think I'm just looking at the trend, and it's just going to get stronger. And you listen to the investor calls, right, for the publicly available investor calls, right, for any company, and AI and data science and machine learning are often talked about positively, right, in those calls, in terms of projects that they've undertaken, and in terms of more projects that they see are going to be relevant in the future. So I think the future is bright, definitely bright for
we
AI.
hope so. We hope so.
Yeah. Both in research and both in the startup ecosystem, and also at the big tech companies, which are all at this point, all the big tech companies right now are either AI first publicly or internally, where they have major efforts to completely change the way they look at certain problems with artificial intelligence. And so across the board, right, I'm being very what's the word? Bullish. I'm being very bullish with respect
Right.
to AI, but I wasn't before. I was bearish, right, the last few years. But the trend, speaks for itself, and I think it's getting stronger. I think there are a few things that we have to be careful about as an industry with the hype. Autonomous driving being one of them. I think that industry is going to have to come to terms with the fact that we're not going to be able to meet the promises that were made, I think, in the last few years with an autonomous driving ecosystem. That might be damaging for the AI industry as a whole. I'm not sure, but I think there are other areas where it's strong, especially in computer vision, and a lot of the great stuff I'm seeing in healthcare right now. Cybersecurity, I think it's going to only help in cybersecurity and fintech, right? I think we've seen the revolution there, where bots do a lot of the bulk of the trading now versus human beings. So yeah, autonomous. I'm a little concerned about the other industries. I feel like AI is just going to continue to have a stronger presence. Mm-hmm.
Yes, really interesting, interesting insight from you. Thank you for giving us time, George. And hopefully we'll talk more in coming weeks. Because you've been doing lots of research, and hopefully when we connect again, you have something new that you have done. So we'll talk about that too.
Great, thank you.
Have a nice day. Take care. Bye bye.
Thanks. Bye bye.